this video we'll see the concept of operators in C with clear explanation, like we'll see each and every operator with a program and execution. We'll see. Myself, Shravan Kumar, Manthri, technical trainer. Yeah, an operator is a symbol that tells the compiler to perform specific mathematical and logical manipulations. Okay, we'll see how these operators can be used, what exactly an operator. Okay, we know some simple like something like plus is an operator, minus is an operator, multiplication is an operator, like this. Not only this, we have any more number of operators. So like they are divided into like this: arithmetic, relational, logical, bitwise, assignment, as well as miscellaneous operators. So all those things we'll see one by one how these operators are there in C, and in different ways also. Not only this, how many different ways we can write. We say like for plus 10 plus 20. So what if I write 10 plus E? What happens? Okay, so will it execute without an error? So that is also we'll see like this. So some interesting topics like an incrementing, decrementing operators. Okay, what are the special cases we have? Okay, what if I write I plus plus comma I comma plus plus I? And not only this, in some operators like logical and very interesting, logical and logical are very interesting. If you write in some if condition, what happens? Okay, so which is a priority, and some interesting thing we'll see here. Okay, like this, and also conditional operator. Not only this, I'll show you everything and different scenarios, like the things which you don't know till now. Some of course you know about operators, but the hidden things, some hidden things which are there in C regarding these operators when you use, might be in conditions or statements or in loops. So how their execution, that also we'll see now. Before we start, please subscribe. You'll get more updates. Okay. Yeah, these are the operators in C. Okay, I covered everything. So first we'll go for arithmetic operators. Okay, the arithmetic operators we have plus, minus, multiplication, division, percentile, plus plus, increment we'll see. And we know this percentile, what is the mod operation? Like if I write 20 percentile 3, what is the remainder? You will get it as 2, right? So that will be printed. What if 20.3 percentile 3? Is it an error? So if it might be an error, then what if I want to get 0.3 as output? So that also we'll see. Okay, so all interesting things I'll show you in this concept of arithmetic operators. So how this can be executed. I'll go directly first with plus operator. Okay, I'll directly go with the execution. Yeah, we can see with the program. Let us suppose I have taken this program, basic program, very basic program. Okay, A value is 10, B value is equals 20, and the C is a one more variable. So all these are taken as integers. Okay, what is C is equals to A plus B. What is A value? 10, B value 20. So will be added as it is a plus operator, and C value will become 30. I'm printing, of course it is integer. Okay, right, I just want to execute this one. Yeah, we can see the output here. It is 30, right? So the output is 30 here. You can see, very simple, we know. Okay, this is simply plus operator, but the other things also we'll see. Another thing is, of course, you can write here C equals to A plus B. This is fine, or you can write like this directly without using that C variable. Directly you can write A plus B. This also gives your perfect output. You can see here 20. Of course I have taken 10 plus 10. Okay, yeah, which is 20. Directly you can get. And now of course I'll take this one as 40. Of course you will get it as 50, right? Yeah, the output is 50. Now the thing is, instead of B, what I want to take is A plus something like 50. Now what will be the output? Will it give an error? Definitely not. Here it is, A is a variable value, 10 plus directly 50 will be taken, which is 60. This is also acceptable, that is fine for plus. Okay, and now can I write like this? Okay, something like if I write D, A plus D. So will it give the exact output? Definitely not. Where D is not a variable, you will get it as error here. But what if I give like this? Okay, D in single quotes. Now you can see it will execute successfully. Why? Because D is not a variable right now, it is a constant, right? A character constant. What is a constant value? Of course we know ASCII values. I'll simply write here. I think for lowercase a the ASCII value starts from 97 up to Z is 122, right? And for uppercase a it starts at 65 and up to Z it is 90, right? So for D you can observe, so A is 97 means B is 98, C 99, D is 100. So now A here it is a variable 10 plus 100 which is 110. You can see the output 110, you will get it. Anyway, here it's, I'll make it as comments. Okay. Now what will be the output if I write like this? I think you can guess. The A value, which is ASCII value, is 97 plus 100 the value. Why? Because it is in single quotes, that's why it takes a character constant value from ASCII. That is, you can see the output which is 97 plus D is 100, 197, you will get it. Yeah, you can see 197, right? Yeah, one more thing you can observe, like what if I write here something like 10, something like I'll write 50. So you may know that 50 plus 100 which is 150, right? Yeah, you can see this is 150. Okay, now one more question. What if I write here something like 5, so but 5 in single quotes, will it work? Will it give correct output? Yes, why not? You can say, but you can say D value is 100. What is 5? It is a character constant, and again we have ASCII values for character constants of the numbers, like for 0 it is 48, right? Like this up to 9 it is 57. So you can observe for 5 what is the value. Okay, 0 is 48, 1 is 49, 2 is 50, 3 is 51, 4 is 52, 5 is 53. So 53 plus 100 which is 153. You can observe what is the output. You can see 153. So like this you can take for the operator plus. So these many ways you can write for evaluation, and not only this, you can write here also. C equals to A plus B is accepted, C equals to A plus 15 is accepted. Afterwards you want to print here the variable value, that is C, so which will become 10 plus 15 25, that is also fine. Okay, here also you can give in single quotes. So this is basic, like for arithmetic operator plus how you can get it. So this part is over. Next we'll go for minus, then multiplication, like this each and every operator we'll see. Now the same rules whatever I have done, those are applicable for minus. I think we know, like instead of plus you can make subtraction. So this will become 10 minus 15 which is minus 5, right? So we'll see that output. Yeah, minus 5. Same thing you can implement here, same like whatever you have done in previous. So if I write C equals to I'll take here as something like, let us suppose this is also fine. I'll take 60 minus, okay, 60, there A value B, A minus B, 60 minus 40 which is 20. Yeah, 20, it is fine. Now can I keep B in single quotes? Let me see what happens. B in single quotes, so which has to be 60 minus B value is 98, right? ASCII values 98. So 60 minus 98, you can see the output which is minus 38. So this is also correct, so there is no error in this. And of course you can keep uppercase B. So what is the value of uppercase B? 65, it starts, right? 66. So 60 minus 66, right? A value 60 minus 66 which is minus 6, right? So that is also very most important. Like, so like this we can have subtraction. This is about subtraction, the second one which we have done for arithmetic operators. Okay, yeah, same thing. If I go with the multiplication, I'll go multiplication A into something like 4. So what happens? A into 4, 60 into 4, which will be 240, right? So we'll see that output. Yeah, 240, right? You can consider A into B. So B value is 40, 60 into 40, 2400, right? Yeah, like this you can take, and here also the same rules are applicable. You can keep in single quotes. Okay, single quotes. So now 60 into B value is 98, right? 98 into 60. I'm not able to calculate, but you can see, I think this is output 5880, 5880. Okay, of course it will print within range the value is. So we know the values, the range of integer we have taken as it is taking 4 bytes here. So it takes for minus 2 power 31 to plus 2 power 31 range values, right? Otherwise it will give garbage. So this is simple about multiplication. Okay, so going to the division part. Division is somewhat somewhat different. Okay, little bit we'll see what is the difference. Okay, division, A divided by B. Okay, so see, I'll take a simple example. Okay, this is for beginners. So I'll take some simple examples. 20 here. Here I'll take what? I'll take 5. So 20 by 5, which we know that the value is 4, right? So the output is 4, right? So like this, but I'll take here, what if I take 22? So we know that the output is 5.4, right? I mean 4.4, right? So the output should be 4.4. You can see the output here, only 4 you got it. So why we got 4 only? That means you have the division where you have taken it as integer, right? You have taken it as integer, that's why it is 4 only. Okay, so the remainder, I mean whatever the decimal positions will be ignored, right? So that is, and of course we know how to get that answer also. Okay, you can take the, see the resultant is float, and there are so many constraints regarding while you take this one, and of course you can take it as float, or I'll take here as float. So now can you observe here? So I said it as C, float C. Anyway, 22 by 5. Okay, I need to close with semicolon. 22 by 5, which is 4.4 I need to get, but you can see whether we'll get 4.4. Anyway, percentile F, right? Here it is a what you call it as, here it is floating value. Now the part you can see whether we'll get 4.4, you can see. Yeah, okay, it's not 4.4, it is 4 followed by n number of, I mean 6 number of zeros, right? Anyway, percentile F, if I write those many zeros, let us suppose if I want only 2 or 3 zeros, if I want 2 zeros, I have to put 0.2 F, so that I'll get only 2 zeros, right? 4.00. Okay, but the thing is I need to get 4.4, but where the logic missed, you can observe here, A is integer, B is integer. Okay, integer by integer, always the resultant is also integer. Okay, that means 22 by 4, 5. First it will give the answer as 4 only, it's not 4.4, it's 4 only, then it is float, that's why it will be taken as the remaining floating are zeros, right? So that is what happens. But in order to get the float value, what you need to do, you have to make it as typecasting. Okay, anyway, I'll explain this one clearly in typecasting video. Okay, how to make type conversions, everything. Right now if I take like this, it's with the one rule, like, so if you take integer by integer, integer by integer, result will be integer, integer by float, result will be float, float by integer, result will be float, and float by float, the result will be float. Okay, yeah, you can see now, I think you will get the answer. Now A value is converted from integer to float. Now the answer you can see, yeah, 4.4, you can see. So this is what you have to do. I'll clearly explain this one in the type conversion by taking more number of examples. Okay, so this is about division operator clearly. Of course you can here also you can take character constants. Okay, the next one is percentile operator. Okay, very most important percentile operator, you can see. Okay, I'll write here A percentile B. Anyway, there is no float required here, right? So percentile is used for getting the remainders, right? Getting the remainders. So 22 by 5, so the quotient is 4 and the remainder is only 2, right? So we'll get that remainder value when you go for percentile. You can observe the output. Yeah, one mistake here, you can see it's percentile not f, right? C is an integer I have taken. Yeah, so now you can observe, so 2 is the remainder, like this, right? So now I'll take something like I'll take 20. Here I'll take 3. Of course we know that the output again, of course again we'll get it as 2, right? The remainder. Okay, so let me take another, or if I take 10 here, so the remainder should be 1, right? Yeah, 1. Okay, yeah. Now the thing is, what if I write 10.5? What if I write 10.5? A equals 10.5. Of course it should be float, right? So I'll take it as float. If I take 10.5, B is 3. Okay, C I have taken. So C equals to A percentile B. So can you guess what will be the output? Just, so will you get an output as 3, what is that, 1.5 as output? We'll see. You can see it is an error. So that means what, percentile which finds the remainder only for integers, right? Anyway, there is a flexibility, there is the one function which gives the remainder for this decimal values also. In general mathematics we feel like you won't find the remainder for decimal, right? So now there is a function called as f mod. Remember, f mod is a function where it will take the decimal or floating values. Now you can see 10.5, if you divide with 3, 3 is 9, the remainder will be 1.5. Okay, that you will get here, where C is a floating point number. Okay, now you can see the output. Okay, we'll see the output. There is no error, you can see 1.5, like this. Okay, if you want to get the more clarity, you can take another values. Okay, I'll take something like 40.5. so I'll take here as, can I take 6? So 6, 36, right? 36, I'll get 4.5. We'll see this output. Yeah, 4.5. So remember this part, what is this? F mod. Okay, F mod when you can use, when you want to find the remainder, when you use the decimal number. So okay, even you can write it as 6.2. So then also you can find the answer. Yeah, like this. Okay, so you can take this F mod for percentile, right? So these 5 operators are finished. Now we'll see the plus plus and minus minus, which are increment and decrement operators. Okay, of course they are unary operators also. Unary operators. See, of course I have to tell about what is unary, binary and ternary operators, right? So unary, that can be operated on only one operand. Like if I write plus plus a, so operand is only one. If I write something like my a minus minus, or if I write minus a, see, like this we'll have this, we call it as unary operators. I'll write something like this operation, tilt of something like a. It's okay, I'll explain everything with execution. The binary operators we know very well, a plus b. Plus is operating on a and b. Okay, so I can write a divided b. Okay, I can I say this is what about this one, a plus b plus c? Is it ternary? No, it is, this plus is a binary on a plus b, this plus is a binary on, might be b plus. If I write something like this, plus is a binary on this resultant and c, so this is also binary, right? So ternary 3 operators. Here we can find one operator called as conditional operator. Okay, this is ternary operator. I'll explain this one also. Ternary operator. Okay, so these are the operators in C. Okay, basically divided, and afterwards we have divided like arithmetic, relational, logical, bitwise assignment and miscellaneous operators. So now we'll see plus plus and minus minus operators with execution. Yeah, let me take int I equals to 5 and I'll take percentage d. Okay, I'll write of course I basically. Okay, anyway I'll take I comma j. Okay, so I'll first print j. What is j? Okay, by writing like this. Okay, j is equals to, okay, before that simply I want to print what is I plus plus. Okay, see I plus plus, and I'll show you the difference. Anyway, both are increments only. Okay, I plus plus means that value 5 will be incremented and then I value will be printed in the next as, what is the next value? 6. Okay, you can see the output. Yeah, the output is 6. Now can I write plus plus I? I can write plus plus I. Again the output you will get it as 6. You can see. Yeah, the output is 6. Now the thing is, you feel like both are same? No, mostly not. Okay, we'll see the difference. Okay, I'll write j equals to plus plus I. Just want to print what is I and what is j. Okay, I'll take here percentage d one more. Yeah, what is the value? Like I equals to 5. Okay, then plus plus I is nothing but it's a pre-increment. Pre-increment means, so first it will increment the value. So 5 will become 6 here, right? That 6 will be assigned to j. So I'll write here. So I value became 6. Okay, then that value will be assigned to j. So both has to be 6, right? You can see the output. Yeah, you can see 6 6, both are 6 6, but we can see the output with another, like what if I write j equals to I plus plus, what happens here? So first I post increment means first the value will be assigned. What is the I value first? 5. So 5 will be assigned. Okay, 5 will be assigned. So I value as it is, I value initially, I value 5 will be assigned to j. So that's why j value will become 5. Initially this value of 5 will be assigned to j, that will be j equals to 5. Now afterwards I value will be incremented to 6. So now you can observe I is 6, j is 5. We'll see this output I comma j. So I is 6, j is 5. I think you can find the difference. Okay, so that is the one thing you have to check it out clearly. And not only here, you can observe here also. See, one more thing here I want to show you. Yeah, now tell me what is the output of this one. Yeah, I is equals to 5. Now 5 value will be incremented. I told you pre-increment, so plus plus I. So 5 I value will become 6, then it will be printed. Next line you can see here the value became 6, right? I became 6, so that 6 will come to the next line. So here what will be printed? First in this line it will print 6, then 6 will be printed. So 6 comma 6, you can see the output. So 6 comma 6, the output you can see. And now the thing is, what if I write I plus plus? So will it 6 comma 6? Okay, we'll see first. It's not 6 comma 6, it is 5 comma 6. You can see how it is means. So first 5 post increment, that's why first the value will be taken by printf. So fifth line number 5 you can see. So I value is 5. So 5 value will be taken, afterwards incremented to the next line. So here what happens here, fifth line the value is 5. Where it comes out of fifth line the value is 6. That's why here I value will be printed as 5. Here the value will be printed as 6. Right? So like this it will be increment and decrement operators. Now the next part, what is the output of this one? some interesting thing. Of course the behavior will be different in different types of compilers. You can use for Turbo C, it will be different. You can go for code blocks, it is somewhat different compared to that, and even if you go for online compiler it will be different, but we'll see how it will be executed. Okay, in general you can feel like I equals to 5, so here it will be 5, right? So if you feel it as here 5, then it will be incremented, then it goes to the next line. I is printing, it is 6, then 6 plus plus, it will be 7, right? So but we'll see the output what it prints. Okay, anyway I'll explain this one clearly. So 677, how it will be. Okay, yeah, the first thing we have to evaluate not from left to right, we have to evaluate from right to left. Remember, we have to evaluate from right to left. Okay, so the first thing what you need to do is here the evaluation. So right side what is there? Plus plus I, right? So that plus plus I you have to take first. Okay, so now I am explaining the first part where you execute in Turbo C, what will be the output you will get. First I'll explain. So 5, the value here plus plus I means it will be 5 plus plus, it will become 6 here. Okay, now I value is 6 will be taken with this I, and I plus plus post increment, anyway here also 6, afterwards I value will become 7 after printing, right? Now this is the output you will get in Turbo C, but right now you got it as 677. I'll tell you how it is 677 means. Anyway, execution till this it is same, okay, but it won't print immediately. Okay, once again I'll tell you. Here you can see, here it is 6 first, okay, here it is 6, now here also 6, now here also initially 6. Now the thing is, after 6 what is I value? Plus plus, so I value will become 7 now, right? I value will become 7 now. Now the replacement will happen for wherever you have I, wherever you have plus plus I. It won't replace for I plus plus. Why? Because it's a post. Pre means now the final I value will be replaced for wherever you have plus plus I. So here plus plus I is there. So here plus plus I is there 7. Here I is there 7 will be taken. Not for, I told you, no, not for this one I plus plus. Okay, same thing happens for online GDB also, and for right now I am using code blocks. Here also it takes the same thing, right? Even you can check it out for another also. Let me, what if I have plus plus I, here initially it is 5 plus plus, it is 6, now 6 plus plus 7, and of course here 7 only, right? 7 only, but the I value will become 8, right? After last, why? Because I plus plus is there. So now 8 will be replaced here, and plus plus I here also 8 will be replaced. So now the output should be 788. Let me check it out, the output. Yeah, you can see 788. Okay, I'll take one more like this. So here also I'll take plus plus I. Okay, let me take here plus plus I, here I plus plus. So like this, what happens we'll see. So I value is 5, anyway it is post increment, value is 5, afterwards I value is 6 comes here, 6 plus plus, here it is 7, and here 7 plus plus, here it is post increment, pre increment, that's why 8. Now the final I value is 8, so wherever you have plus plus I or I will be replaced with 8, right? Here plus plus I replaced with I. Anyway, the third one is I plus plus, it won't replace. This output will be 885. We can see this one. Yeah, you can see 885. So this is what the replacement happens. And now one more final. I'll take I here. So which will become 5. Okay, 5 plus plus 6. 6 will be here. And 6 plus plus 7. 7 will be here. And wherever you have final value is 7. and here I is there, that's why that will be replaced with 775 will be your output. You can see the output. So 775, and of course the final one is decrement operator. Same rules will be applicable for decrement. So whatever I explained. So one example I'll take. It is like decrementing. One value will be decremented. Okay, here if you take decrement, if I write minus minus I, that means 5 value will be decremented, then only prints the value will be 4. Yeah, you can see the answer as 4. And what if I write my I minus minus? So the output will be 5 only. That means afterwards it will be decremented, and the rules whatever I explained for plus plus, same thing will be applied for minus minus. Okay, one example of taking more than one decrement operator in a print statement. Okay, yeah, I, then I'll take plus plus I. Okay, the answer would be, so the first one is plus. Okay, I'll take minus minus, right? Here minus minus I value will be decremented to 4. Okay, now I value is 4. Here 4, here 4 anyway first, then decrements I value to 3. So now I value is 3, right? So 3 means wherever you have minus minus I, and I will be replaced with 3. So last one is 3, and here I is there, that's why 3. So I minus minus will be as it is. So output is 433. You can see 433. So this is what happens with the operators, how they can be. And if you have any doubts regarding this increment, and you can post me in the comment section. This is all about arithmetic operators. I explained each and everything. So now we'll see the logical operators. So what are these three, and we'll see with the program and executions. Of course there are 3 logical operators. This is we call it as logical and this is logical or, this is logical not, right? So double and 2 ampersand symbols has to be given, 2 and symbols, 2 or symbols, and 1 not symbol. So we'll see what are these symbols, how this can be worked. Anyway, it's also a binary operators. All these, I mean these 2 are binary operators, and of course it's a unary. So I'll let you know what is this. Okay, first it operates on the values which are either true or false. Okay, it operates on either true or false based on this. So we'll get 4 possibilities, right? So like both are true, one is true, one is false, one is false, one is true, and both are false. So now if I say logical and means if both the values are true, then only true, otherwise it is false. If any one is false, so the resultant will be false. So what about logical or? If both are false, then only false, right? If any one is true, I can write it as true. What about not? If there is true, it will become false. If there is a false, it will become true. Let us suppose this is something like A, this is something like B. So not of A if I write, so here true, it only operates on one operand, right? So it will become false. True means false, false means true, false means true. So if I operate on B, not on B, it is true, then it is will be false. Here it is false means true. So this one, so true means false, false means true. So like this we'll get. So I think this basic we need to have before going to this and logical and operators. Okay, so how this can be done, like in our C programming in compilation. So we'll write some statement where both the values are true, means both the values are non-zero. Okay, true in the sense if you give both the values are non-zero, any value which is non-zero will be taken as true. So any value which is 0 will be taken as false, right? So like this, if I take 2 non-zero values, then it will be true. Okay, like this we'll get. Okay, but see, if we give the values, all non-zero can be taken as true and 0 is a false. But when a computer wants to return the output, okay, when it wants to return the output as 0, when it wants to return false, it will provide 0. When it wants to return true, it gives 1. Okay, remember this point. So when we give non-zero, it is true. When compiler wants to return true, it returns 1. Okay, yeah, we'll see with examples. I have taken a simple program where it can find the largest of 3 number. I have given 3 numbers. Of course, assume that three numbers are different. Okay, something those where there is no common value for these 3. Okay, I'll take a equals 10, something like this. B equals 8, C equals something like I'll take 7. Okay, yeah, if I give like this, I think we know that 10 is the largest one. How it can be get? So if A is greater than B, it is checking. Anyway, greater than, it is checking what is this value. 10 is greater than 8, it is true, right? So B is greater, A is greater than C, 10 is greater than 7 is true. Of course, remember one more point, we are assuming it as true, but the compiler takes true means it's something non-zero value. Here it is 1, and here also 1. So 1 and 1, or true and true. Of course, true means 1, right? Or non-zero, any value. So 1, right? So this if condition value is 1. So this is what? If 1 means true, right? If any non-zero also true, right? If any non-zero including 1, right? So if will be executed. If you get 0 here, else will be executed, right? So like this it will happen. Here you can see 10 is greater than 8, 10 is greater than 7. So percentage D is greater, which is your 10 is greater, it will print directly. Okay, that's it. So anyway, let us take another value here. Here I'll take 5. Let us suppose. So 5 is greater than 8. Is it true? False, right? So it is false. False, and 5 is greater than 7. Again false, right? False and false. The resultant will be false, right? Which is 0 and 0, which is 0. So if of 0 is false, so it will come here, else part. Now 8 is greater than 7. Yes, true. True means 1. So 1 means, so B is greater, 8 is greater, right? So 5, 8, 7, which is the highest? 8. Okay, take another constraint. Here I'll take 15. So 5, 8, 15, you have to get 15. You can see 5 is greater than 8, false. 5 is greater than 15, of course false. Here it comes 8 is greater than 15, false. So here else part, which is 15, is your answer. One more interesting part, okay, that is we need to learn actually. So let us suppose here I have taken something value. Let me take here again I'll take A equals to 10. 10 is greater than 8. Yes, true. Okay, yeah, remember this point. If this is true, then only this can be taken. There is a very interesting point here. 10 is greater than 8, then it is true, then it will check this one, otherwise directly goes out of if condition. Okay, let me take here something like 5. See, 5 is greater than 8. 5 is greater than 8, false. So if it is false means 0, right? Then it won't take this one. Remember this point clearly. Anyway, I explained to get the basic knowledge in the previous, but actual happens is this one. So if this value is false, directly comes out. It won't take this one. It won't be executed. You can see 5 is greater than 8, directly comes to the else part. Okay, so why like this happens? This is a very interesting logic. If you take in the truth table, once again I'll go to the truth table, this one, if first one is true, then you can see there is a chance of getting true. Okay, if first one is true, might be if it is false, you will get. But if first one is false, directly the answer is false, you can see. So that means if the first value is false, so definitely you will get the answer as 0, right? If it is false. So that's why, so this is, we call it as lazy execution actually. So that's why if it is false, where is the need to execute this one? Why? Because even if it is whatever it may be, if it is true or false, the result will be false. So that's why it won't be executed. So then it comes here. So when you write two operations in logical AND, this is a very most interesting thing. Anyway, I'll explain clearly this one with another example. Okay, so for this one you can see it will check and like this it will happen. Okay, we'll see some interesting program. Yeah, Let me consider this example, this program. So x equals 1, y equals 0, z equals to 5. What is a equals to y double and z plus plus? What is y? 0. 0 double and I told you 0 means false, right? 0 means false. False double and something. So it's always false. That's why this is the part will not be executed. Okay, this part will not be executed. So z value will be as it is. It won't be changed to 5. Okay, even if you take plus plus z also. Okay, I'll take anyway plus plus z. Let me see. So z value is 5 only. You can see. You observe what is z value if I ask you. Yeah, you can see the output, that is 5, right? So now what I'll do is I'll change y value as 1. So I'll change y value as 1. Now the thing you can see, 1 in the sense true. True means true and something. We cannot say whether it is entire thing is true or false. True and true is true, true and false is false. So now there is a need of plus plus z. That's why it will take z value. So z value will become 6, non-zero. So non-zero and non-zero, which is true. A value is true and it is asking z. What is z will be? Now it is 6, you can see. So this is a very interesting point that you can observe, especially in logical and as well as logical OR also. Okay, same thing, like let me take logical OR. Anyone, right? Either of this condition or that condition, right? Now if I take this one in logical OR, so there is a constraint that if first one is true, irrespective of the second one, it always will become true, right? So it is reverse. If y equals to 1 means 1 or something is always 1. So that's why z value will never change. So that's why this value will become 5. You can see it is 5 only, right? But whenever I keep it as 0, now you can see 0 or something, we cannot say 0 or 1 is 1, 0 or 0 is 0. So that's why now this will be executed. Now the answer of z will be 6. So this is 6. Okay, so like this it will be. This is a very interesting point. And now one more thing. Okay, what I'll write here is x double and y or plus plus z. Okay, so like this I'll consider. Okay, x double and what is x value? 1, right? X value 1. Then okay, anyway I'll ask like what is a value. Okay, the resultant I want actual. So now x equals 1 and something I cannot say. So that's why 1 and this has to be executed, right? Y, what is y? 0. So 1 and 0 is 0. So x and y is 0, 0 or something. We cannot say exactly, right? So we cannot say exactly plus plus z, which is 6. So that's why, okay, I'll write here what are the values. You'll have 1 double and 0, okay, slash, then z value anyway will be 6, right? So anyway, that afterwards we have to check it out. 1 double and 0, which will become 0, right? Now the 0 or something, we cannot say exactly 0 or 1 is 1, 0 or 0 is 0. So that's why now this will be executed, 0 or 6, right? Which is non-zero means which is equals to again 1, right? So false or true is true. So a value will be now executed, a value will be 1. And anyway, for your clarity, I'll print z also. Okay, we'll see a value is 1, z value is 6. You can see the output now. Yeah, 1 comma 6, right? So this is what an interesting point we can observe in logical and logical or operator. And one more thing we can check it out. I'll keep here or, and here I'll keep and. Now in this case, remember this point, if you give or and, okay, you thought of first I have to do x or y, but remember if I have logical or and logical and, the first priority will be given to and only. So that means first you have to complete this one, then only you have to go for or condition. Remember this point carefully. So because as per the priority I'll show you here what is the priority rules. Okay, operator precedence rules we call them as logical AND is higher prior compared to the logical OR. So like this we need to execute, and still you want it clearly. I have one more program you can see here. So I equals 0, j equals 0, I double AND j equals to I plus 10. See, when this j equals to I plus 10 will be executed whenever I value is 1. Why? Because 1 and something is we have to have, but 0 and something is always 0. That's why it won't be executed. For this case I equals 0, so 0 and something means j value will not be changed, right? So j has to be printed as 0. You can check it out. Of course you can write int main there. When you write int main, you have to write here as return 0. I have written void main, then nothing is required at the end to return. So if I execute, you can see 0 is our answer. So why? Because here this part is not executing. So let us suppose if I give other than 0, I'll give something like 1 or whatever it may be. Non-zero I can keep something like 15 or whatever, or 158, something non-zero. So that means non-zero and this has to be executed. So what is I value? 158 plus 10, which is 168. J value should be 168. You can see, yeah, 168. So like this it will execute. These are some interesting and hidden things which we have in logical and logical OR operator. I think you can guess the output of this one. So this is 1, this is AND 0 anyway, AND is a first priority, 1 and 0 is 0 or something which is required. So Z value will be definitely incremented. So Z is 6. Option A is the correct answer. So this is the operator precedence table where the priority, if you take two operators, which is on the top will be the first priority. If I take multiplication and plus, multiplication is on top, that's why this is higher priority compared to plus. If both are in same, let us suppose multiplication and division, if both are in same line means you have to take this associativity left to right, which comes in the left, multiplication. In your question with this operator which comes first, that will be the highest priority. So anyway, I'll make one video regarding this, about this operator precedence. And in our question and OR, you can see which is on the top and compared with OR. So always you have to do AND operator first. Okay, so like this we have. Of course this is a one more question, try to get the answer if you are able to. Anyway, I'll explain this one afterwards in the next video. So this is what relational operators now we can see. You want more interesting stuff? So please subscribe by clicking on the subscribe button below. Anyway, there is no much logic in this. It's something like same logic will be applied like we'll see in mathematical concepts, like what is greater than, what is less than. It's simply like greater than followed by equals to. You have to put here less than or equals to, and this is something different. So this double equals to, like if I say double equals to means if I say A double equals to B, the meaning is whether these two values are same, then it returns true, which is equals to 1. So if both the values are not same, then it returns 0, which means that false. Okay, let us suppose if I give A value as 8, B also 8, then it returns 1. A value as 8 and B value is something like 5. Okay, then it returns 0. So that is what double equals to. Remember this point. If I write A single equals to B means your B value will be assigned to A. Okay, which is nothing but, let us suppose if B value is something like 8, so 8 will be assigned to A. Okay, so something like here it is assignment operator. Anyway, I'll explain this one. It's something like, let us suppose B equals 10, A equals to 5. So now if I write A equals to B, the meaning here is your value 10 will be assigned to A. That means your A value will be replaced with 10. So anyway, B is as it is. So this is what happens if you go for single equals to, and this is double equals to, which is a comparison or relation operator. So completely reverse, this is not equals to. Like if they are not equal, then it returns 1, otherwise it returns true. Okay, and greater than, if the first one is greater than second one, like this, and this one A less than B. Okay, we know like this, A, the first one is less than second one. Okay, and this is whether not only checking greater than, it checks the equality also. So I want to show you some simple programs. Okay, I'll take 3 examples, different programming examples, and I'll show you how these can be written in C language. Yeah, the first example you can see, which is very simple one. I've taken a value 7, b is equals to 5. So now if a is greater than b, simple checking like whether your a value is greater than b. If it is true, that means the value will be 1, right? The value here it is 1. If it is non-zero, definitely it returns true, right? So 7 is greater than 5, yes, true. So that's why it returns that %ALD means a is 7 is larger, and else if that is not, b is greater than a. So like this we can keep, and we'll try anyway. We know this output as 7, right? Yeah, so here 7 is larger, right? Now the thing is, okay, anyway I want to do some like here we can see if I write something here also 7, and I think now the answer will be both are same, right? So 7 is not greater than 7. Okay, 7 is not, I mean the second value b is not greater than a, so then definitely it takes both are same. Okay, now my question is what if I write like this, if of a. Okay, so if of a, the first thing what you need to check it out, if I write if of a, will it give any error? Definitely no, not error. So what if of a means, what is a value 7, which is always which is non-zero. Non-zero means always true, right? So that's why if of 7 means if of non-zero true means this will be executed simply. Okay, so you can see the output will be something, this printf statement you can observe. Yeah, 7 is larger. So let me take if it is 0, a value is 0. Okay, then I think it has to come here, else if, right? So else if, I'll write simply. Okay, anyway I'll remove this one simply. So now I'll write like this, very simple statement. Okay, if of a means 0 means, so this is false, that means directly it comes to the else part, right? So the output will be something like both are same, right? So both are same. So this is all we need to remember. It's not at all an error if you write like this. Okay, this is a one basic example you can take, and somewhat one more example. It is based on some priority. So what can be the output of this one? If you consider a value is 500, b value is 100. So here it is not a, right? It is not a. That means not a greater than or equals 400. I think your answer will change. So based on which you will take first, whether not or greater than or equals to. Okay, of course we know not is a logical operator, we learned, and not of a shall I take first, or a is greater than 400. So see, if a equals to 500, if I take first, 500 is greater than or equals 400, if I take, it is true. For the true it is not means false, means directly it won't change this one, right? So this is the one thing we can take. Anyway even not a also, if we take, anyway it goes to the false part. Let me take here something like, yeah, I'll take here a equals to 50. 50 is greater than 400, false. Then not of false is true, then b value will become true if I take like this. But this is not correct. First thing you have to check it out, not a, first priority will be given to not of a. So 50, not of 50, not of non-zero is 0, right? So this entire will become 0. Any of, not of any non-zero will become 0. 0 is greater than or equals 400, false. So that's why this one statement will not be executed. Anyway, this one statement is inside the if condition, right? So b value will be 100 as it is, a value will be 50 as it is, right? So now you can see the answer anyways equals to 100. So 100 and 200. So b value is unchanged. So like this we have to consider, right? Let us suppose if I take this as 0, a equals 0. So not of 0 is true, right? Let me take like this. So what is not of 50 is 0, right? So 0 is greater than or equals 0, yes, true. So that's why b value will become 300. You can see the output. Yeah, b value is changed as 300. So like this we need to observe how this can be taken. So which priority is first compared like not and greater than, not will be taken first. Now the third one, of course, very simple, you can observe here. So what is the answer for this one? I told you like A double equals to B. First you have to do this one. So what is A 7? What is B 5? Are they equal? No. So that's why this value will become 0. So C equals to 0. You can see. So now you can see. So C value is 0. Now let me take both the values are same. Now C value will become 1, right? You can see here the output. So that is what, if both the values are same, that means the comparison value will be 1. So that will be assigned to C. So like this we can consider. Now can you try this one? So what is the answer for this one? So A equals 10, B equals 2. This is one operation expression is given. So you can see double AND is there like this. So how you have to consider? Okay. So the first thing you have to observe here is inside the braces. So C double equals to C double equals to C. So I told you first the relational. So what is C value? Nothing is given but some garbage value. See, whatever the garbage here is taken, definitely the same will be taken here, right? So anyway I didn't assign anywhere. So some garbage equals to garbage, both will be same, that's why it returns 1. So now C value will become 1. So I'll write here C value will become 1. Now not of 1. Not of 1 means its entire will become 0, right? So this entire will become 0. So 0 double AND. I told you in the logical operators, like in logical AND, if first one is 0, the second part will not be executed. That's why this increment will not happen, right? So that's why B value is 2 as it is. A value is 10. Till now A is 10. Okay. So now 0 double AND something, which whatever it may be true or false, it will become 0, right? 0 double AND something. So this 0 will be assigned to A. So now A value will become 0, right? So now here one more statement, C plus C equals to, what is the meaning of plus equals to? If I say C plus C equals to something A, means C equals to C plus A. Anyway, I'll cover this one in assignment operators. Now you can observe here C plus C equals to means C equals to C plus this entire. So what is the value of this one? A. What is A value? 0. Now B minus minus, anyway it's a post decrement, right? So first what is B value? 2 will be taken, then afterwards B value will become 1. So first it has to be taken as 2, right? Posting decrement. So what is 0 plus 2? 2. So here 2. See what is C value? 1. 1 plus 2, now C value will become 3. So these are the modifications will be happened, and now that is asking the order BCA. B is 1, C is 3, A is 0. So option C is a correct answer. So this is what the logics you have to remember, the priorities, how you have to do. Whenever you want to do like this problem to solve, you have to know logical operators, you have to know how to take the increment and decrement, and how to take the relational operators, and about post and pre, and also assignment operators. I think this problem consists of all these arithmetic operators, all these operators, right? So like this we have to do. So now we'll see this bitwise operators, and especially about this tilt or some negation operator, how it will react. So all these things we'll see. These are bitwise operators. It will anyway, it will operate according to the bit value of a number. Okay, according to the bit value of a number. I'll show you how it will be considered. So anyway, we'll take some example, like I'll take A is as 5, B is something like 6. Okay. So now what is AND operator? First thing, these are bitwise operators. First you convert them into bits. Okay, A equals to 5, which is equals to 0 1 0 1, and B is equals to 6, so which is 0 1 1 0, right? So now anyway, AND operator, I told you, if both the values are true, that means if both the values are 1, then only 1, otherwise 0, right? So based on that concept, if I do AND operation, so A and B, what is the value here you will get? You can check it out. 1 and 0. So Anyway, 1 and 0 is 0, 0 and 1 is 0, 1 and 1 1, 0 and 0 0, right? So the value is 0 1 0 0 means which is equals to 4. So A and B, what is the value? 4. Now if I take OR operation, A or B, I told you like OR means if both the values are 0 then only 0, otherwise 1, right? If both are 0 then only 0. If I take this two, 1 or 0 1, 0 or 1 1, 1 or 1 1, 0 or 0 0. So the answer is 0 1 1 1, which is 7, right? Now if I take this one, exclusive OR, which is where if the values are same then it is 0. That means if 0 XOR 0 or 1 XOR 1, which is 0, otherwise 1. So based on this, if I write, you can see here 1 XOR 0 is 1, right? Both are not same. 0 XOR 1, again 1. 1 XOR 1, both are same, that's why 0. 0 XOR 0 0, so which is 3, right? So now I'll discuss this at the last. So we'll see this one, left shift and right shift. So what is this left shift and what is this right shift? So let us suppose if I write A left shift by 1. What is A left shift by 1? First of all, I'll take the value here. What is the value? 0 1 0 1. What is a value? 5. So now left shift means you shift this one here, so this 0 here, this 1 here, and this can be ignored. And extreme right is empty, right? This always you keep it as 0. Now what is the value? 1 0 1 0 means 10, right? So this is binary, this is decimal. Okay, now if I write A left shift by 2 times, okay, this is a 1 time. Now one more time you shift, so this 0 here, this 1 here, this 0 here, this 1 here. Now extreme rightmost will be 0. So this is 1 0 1 0 0, which is 20, right? So what if I ask you A left shift by 6? Will you do like this 6 times? So there is a formula we have. What is the formula means? So it is A into 2 power number of shifts. Okay, let me take my example. A is 5, 5 into 1 shift, so 2 power 1, 5 into 2, which is 10, our first answer. 2 shifts, 5 into 2 power 2, which is 20. So like this, if I take 6 means A into 5 into 2 power 6 times. So that will be your answer. What is 2 power 6, which is 64, 64 into 5, which is 320, right? So like this we have to consider. Directly you can get the answer by taking this formula, A into 2 power S, which is S means number of shifts, A is a number. Now similarly, if I consider right shift, A right shift by 1, let us suppose. So that means by taking the number 0 1 0, you have to shift each bit right side. Anyway, left shift you started from right, right? So from right shift you have to start from left. This 0 here, this 1 here, this 0 here. Anyway, one bit will be ignored. Anyway, if you keep here 0, which makes no sense, right? So 0 0 1 0, which is 2, right? If I say A right shift by 2 times, so this 0 here, this 0 here, this 1 here, so which is equals to 1. So what if I ask you A right shift by 6 times? So here also formula A by 2 power S. Okay, so check it out. 5 by 2 power 1, 5 by 2. Anyway, I'll take integer value, which is 2, right? Now 5 by 2 power 2, 2 shifts, 5 by 4, which is 1, right? So like this we need to consider. Anyway, 5 by 2 power 6, which is 5 by 64, which is 0, right? So you will get 0 here, right? So like this we need to consider for right shift operation. This is left shift operation. So finally coming to this tilt operator. And one more thing, you can write like this also, A left shift by B. That means that 5 will be shifted B times. What is B value? 6. So like this also you can write. Okay, and this tilt is a unary operator. Let us suppose if I write tilt A or negation of A, what is the meaning? Okay, or tilt or 5, what is the meaning? Which is opposite number. Tilt of 5, what is the opposite in negative? Can I say it is minus 5? No. Why? Because you can see it's not minus 5, it is minus 6. So how it is minus 6 means, so I'll write first negative numbers. Negative number starts from minus 1, right? Minus 3 like this, minus 5, minus 6, minus 7 like this. Positive number starts from 0, 1, 2, 3, 4, 5, 6. Now you can see these two are tilt. So like tilt of minus 1 is 0, tilt of 0 is minus 1. You can see in the execution also. Tilt of 1 is minus 2, tilt of minus 2 is 1. Okay, like this. So tilt of 6 is minus 7, tilt of minus 7 is 6. So anyway, this also I'll show you with execution. Okay, or tilt of, you can write like this, tilt of something like x is equals to, what we can write here is minus of x plus 1, right? So you can observe if x is 6, so 6 plus 1 7, minus 7. If I take x value as minus 7, minus 7 plus 1 minus 6, minus 6 of minus, which is 6. So like this. So this is a formula you have to use. So like this we have, anyway we have seen this how bitwise operators are working. I will show you with execution. See here, you can observe a equals to 5, b equals 6. You can see a and b we have done, we got some answer, a or b, a XOR, like this. Okay, we'll see whether our answers are correct or not. So now we'll see this output. Yeah, a and b, 5 and 6, which is 4, we got it right. Same thing, 100 we got it, which is 4. A or b, which is 7, 111 we got it. A XOR b, you can see here. And a left shift by 3 times. I told you the formula. A value is 5, right? 5 into 2 power 3. Yeah, anyway here it is, I have given 1, right? Yeah. Now we'll see this execution. Yeah, a and b, which is 4, we got it right. 100 means 4. A or b, which is 7, 111. A XOR b, you can see that also 011, which is 3. A left shift by 3 times. I told you the formula. 5 into 2 power 3. 2 power 3 is 8. 8 into 5, 40. A right shift by 2. We got 1, right? Now you can see tilt of a 5. 5, the tilt value is minus 6. I told you, no? So if I give a value as minus 6 means you will get 5, right? So like this you will get the outputs. Even you can check for another values also. You can change these values and you will get the answers, right? So like this you can execute these bitwise operators, and these values are very much important if you go for typical programming, scenario based programming. Okay, so now we'll see this assignment operators, of course, as well as this miscellaneous operators also, what is size of how the values will be taken, and also one ternary operator, that is conditional operator, that also we'll see now. You want more interesting stuff, so please subscribe by clicking on the subscribe button below. First, coming to this assignment operators. What is assignment operators here? Okay, the simple one is equals to, where it will assign whatever the left side value, something like I can write a equals to b. Whatever the value of b can be assigned to a, or I can write a equals to b plus 10. So the resultant will be stored here, or I can write a equals to b plus c, or whatever it may be, b into c. I can write, okay, like this it will be taken, it will be assigned. And what if, can I write a plus b equals to c plus d? So this statement is wrong if you consider in the part of C programming. Why? Because you can say this c plus d, the value will be assigned to whom? So left hand side, the value must be only a valid variable. Even it should not be a constant also. So the left part should be definitely a variable equals to expression. So that has to be maintained. Like this you can write. And what about this plus equals to? So let us suppose if I write a plus equals to 10, the meaning is a equals to a plus 10. Okay, so where let us suppose a value is 5, after this a value will become 15. So that's simple, very simple. Okay, if I write a plus equals to 1, the meaning is a equals to a plus 1, right? So which is also equals to plus a, which is also equals to a plus plus, right? So of course in some situations this will be changed, I mean this reacts different, right? So similarly a minus equals to 1. What is that? A equals to a minus 1, which is equals to minus minus a, and which is equals to a minus minus. So this is what, and like this also I explained about minus equals to into equals to, something like I can write a into equals to b, let us suppose, which is equals to a into a equals to a into b. Similarly division equals to, percentile equals to. So what about percentile equals to? Like a equals to a percent a, let us suppose a percentile equals to 3, so which is equals to a percentile 3. So a value, let us suppose 5, which will return remainder as 2. So like this. And left shift also you can write a left shift equals to 2, means what? A equals to a left shift 2. So after doing left shift, then it will be assigned to the same variable. So that means after the expression you are doing the operation on one variable and storing in the same variable, then you can use this assignment operators. Similarly right shift also, bitwise and also XOR also, and logical, I mean XOR bitwise OR also. So like this we can take, and these are all valid statements and you can write in the programming. Okay, so I'll just try to execute these things. So I have written here simply a left shift. So I have written a left shift is equals to 1, means which is equals to a which is a left shift by 1, right? So you have to do first a left shift, then whatever the resultant will be again stored in a. So if I left shift a, the value 5, I think we know that the answer is 5 into 2 power 1, which is 10. Okay, so the 10 again stored in a, and that value you can see, so 10, directly you are getting the value 10. Similarly you can do for right shift also. So this is not at all an error and you are getting the value 2. Same like you can do a equals to 5 and you write a plus equals to 4. That means a value will become now a equals to 5 plus 4, which is 9, right? So I'll write simply a. So what is a value now? It will become 9. You can see here 9. Similarly you can keep any operator, like multiplication I'll keep. So now 5 into 4, which is 20, right? So you'll get 20 here. So like this you can take any of the operators which are, we call them as assignment operators. So moving on to the next one, miscellaneous operators, like what is size of. This AND is different from whatever the bitwise AND. This is address operator. Of course we mostly use in scanf, right, where you want to read the elements. Okay, and this is with respect to, it's different from multiplication operator. This is pointer operator. Of course the concept of pointers in C I explained in my video lectures. You can watch those things. And this is a ternary operator. I'll tell you how this can be executed. Now first, if I go with the size of operator, so size of something, any variable or whatever you give, which gives the, what is the memory, how many bytes of the memory will be allocated for a particular variable, it only does that one. Okay, it only does that one, and it calculates how many bytes will be allocated for that particular variable. Let us suppose if I write int a, if I ask you what is size of a, there is no space here, so the output will be, anyway, if integer, if of course in all advanced compiler it is taking 4 bytes, and in old compilers in Turbo C it is taking 2 bytes. Now it is taking 4 bytes, that's why the answer will be 4, like this. Okay, so that is what you can find it out in size of, and it won't do any arithmetic or operations. Okay, that also we'll check it out how this can be executed. Now I'll take here a equals to 5. Okay, here I'll take, instead of a, I'll take size of. So my compiler code blocks which takes 4 bytes for integer, so that's why your answer must be 4, right? So you can see the answer, so 4. So anyway, you can check for long int also. So long int, let me check how many bytes it is. See, it is with irrespective of your value assigned. So long int also it is taking 4. Anyways, in some compilers it will be 8. You can check it out. Okay, even if you don't give any value also, there is no error. Why? Because it is all with respect to the data type. You can see the answer, and you can find for anything, like if you don't know the data type for any variable, how much it is taking in a particular compiler. Let us suppose double. So if let us suppose if I don't know, okay, then I can keep double and write like this. See, double means can I keep the what is that, this format specified to be changed? No. Why? Because that size of operator, the value will be always an integer, right? So that's why percentile d only you have to keep. You cannot keep like percentile f for float, not like that here. So why? Because the value will be an integer value. So for double, how much it is taking? So 8, right? So let me take one example. Let us suppose if I write size of plus plus a, okay, so is it, let us suppose if I give something like int a is equals to 5. So in this case also, what is the value size of plus plus a? Of course you know that it is, of course it depends on your data type. That's why you feel like it is 4 bytes, right? So now my question is, so what is a value? I'm not printing size of, here I'm printing size of, it is what is a value. So what will be the output of this program? Is it first it will print 4 bytes here, there is no doubt. What about this? Will it print 6 or 5 only? Okay, will it increment here? So that we need to check it out. Let me see. Yeah, 4 and 5, the value of a is not changed, right? So what is our conclusion? Whatever the operations you do here inside of size will not be reflected. Whatever you do, okay, plus plus a or minus minus a will not be reflected, or a equals to a plus 20 will not be reflected. So even in this case also, your value must be a is 5 only. You can check it out. Yeah, you can see it is not changing. So this is the one thing you need to remember, especially about size of operator. So coming to the last one, that is ternary operator. So it will be like this. Let us suppose in generally if condition you use, if you let us suppose I want to find largest of two numbers, we'll write something like this, right? If a greater than b, a is largest, otherwise b is largest. So here in one line you can write c a greater than b, then which is greater, a, otherwise b, right? This has to be assigned to a variable c. Okay, let us suppose if I write, let us suppose if I give a equals to 10, b equals something like 5. So 10 greater than 5, yes, true, 1 the value. So that means if it is true, first value will be taken, right? So what is the first? 10 will be assigned to c. Okay, let us suppose if I write here 5, here if I write 10, 5 greater than 10, no. So that's why it takes the second value. What is the second value? Again 10. Now can I conclude that this one line statement always gives largest of two numbers, whatever the values you give? So like this, if you want to find the smallest of two numbers, what you have to do, in place of greater than you have to keep less than, a less than b, ternary a colon b. This always gives smallest of two numbers to be assigned to the variable c, right? Like this. And not only that, you can write like this also, a greater than b, ternary, whatever the values, 1 colon 0 or 1 colon a, whatever the values you can give. If it is true, if the value is 1, then first value will be taken. If it is 0, second will be taken. And you can write like this also, c equals to something a, ternary a colon b. So this is also absolutely perfect statement. This also will be executed without errors. So all this we'll see with execution now. Now we can see this statement. So A is 15, B is 10. So 15 is greater than 10, fine. So A, which is 15, will be taken. So the value of C is 15, you can see the output. So value is 15, you can see. I'll just interchange the values. Again, you can see 10 is greater than 15, no. So that's why second value B, which is 15. Yeah, this is also fine, right? Yeah, now you can write, can I write like this? A double equals to B. Will it check? Yes, compare 10 double equals 15. No, so that's why second value B, 15 will be assigned to C. So the answer is 15. So you can see answer is 15. And you can write simply like this A. So what is A value? 10, right? 10 is non-zero, right? Non-zero means true. True means first value will be taken, right? First value will be taken. What is the first value? 10. So like this it will be taken. And let me take like this, which is 0. So A equals 0. 0 means false. So B, what is the B value? 15. So like this also you can give 15 is the answer. And one more thing I want to highlight here. Let us suppose if I have more than one ternary operator, which can be taken first. So that is also very most important. Now you can see here I have more than one ternary operator. So which can be taken first? So remember this point, whenever there are more than one ternary, always you have to take from right side. So right to left execution has to be done. That means here. So this part has to be executed. So what is B greater than C? What is B greater than C? 15 is greater than 8. Is it true? Yes. So B means 15 will be taken. So this entire part will be 15. This part is over. And now this has to be done. A greater than C. Is it true? 10 greater than 8? No. So 10 greater than 8? Yes, true. So A value. What is A value? 10. 10 will be taken. So 10 colon 15. Now it will be asked here, what is A greater than B? 10 greater than 15. Is it true? No. If it is true, first value 10. If it is not, second value 15 will be taken. So now the answer is 15, right? So here D value means, what is D value? 15 will be printed. So you can see the output. So 15. So like this, whenever you have more than one ternary operator, you have to execute from right side. So this part will be, what is the result? 15. This part result is 10. 10 colon 15. So A greater than B, if it is true, first value false, second value will be taken and assigned to the D. So that will be your output. So we have seen all the operators in C. So if you have any sort of the clarifications, you can comment in the comment section. I'll clarify your doubts. So we'll see the type conversions in the next video lecture. Thank you.